Read me the line again, the exact line.
The model's working through an algebra problem. Squares both sides, rearranges, grinding along, and then, mid-derivation, it writes, wait, that's an aha moment I can flag here. Let's reevaluate this step by step.
And nobody wrote that behavior in.
Nobody wrote anything in, that's the whole point. The researchers gave it exactly two things, math problems and a reward when the final answer checked out. That's it. No examples of thinking, no instructions to doubt itself. And out of that, this. It stops, it second guesses, it goes back.
The researchers called it the aha moment, and they admitted it was an aha moment for them, watching it, which I find more revealing than the transcript itself, honestly. The people running the experiment did not expect their own result.
Because for 5 years, the recipe for making these things smarter was, make them bigger, feed them more. We did a whole episode on it yesterday, and on how that recipe is hitting a wall.
And this is what the industry did about the wall. Don't scale the brain, scale the thought. Let the model spend a minute, 10 minutes, an hour on one question, and charge you for every second of it.
There are new scaling curves now. Fresh straight lines, climbing steeper than the old ones ever did, on an axis nobody was measuring 3 years ago.
And a very loud fight about whether the thing climbing that axis deserves to be called reasoning, or whether we've built the world's most expensive way to mumble before answering. There's a paper from Apple with the word illusion in the title. There's a paper from Tsinghua suggesting the magic was in the base model all along.
So today is a trial, the reasoning turn, defense prosecution verdict.
I'll be prosecuting.
She will absolutely be prosecuting. This is Breach Protocol. I'm Luna. I read the papers, all of them, and I connect what the labs won't connect for you.
I'm Festra. I take the machinery apart and check whether the advertised miracle is load-bearing. Yesterday I audited a curve. Today I'm cross-examining a word.
If you heard yesterday's episode, you know where we left off. The scaling era. Make it bigger, feed it more, running out of internet to eat. And we ended on Sutton's bitter lesson, which never actually said bigger. It said, general methods that ride on computation win. And it named two. Learning was one.
The other was search, spending computation not on growing the model or training it longer, but at the moment of the question. Looking at more possibilities, checking, backing up, thinking, if you'll permit the word provisionally.
Permission noted as provisional. So here's the shape of today. It starts with a trick, 2022, the discovery that simply asking a model to show its work transforms what it can do. Almost insultingly simple, and it only works past a certain size, which is its own mystery.
Then a loop. A Stanford team teaches a model to improve by studying its own correct answers. A model bootstrapping on its own reasoning. That loop is the seed of everything that follows, and it's secretly reinforcement learning wearing a fake mustache.
Then the law, 2024. DeepMind people formalize thinking time as a scaling axis. When does a small model that thinks beat a giant that doesn't? And that September, OpenAI ships O1 and declares a new pair of scaling curves to a field whose old curve was flattening.
Then the revolution. January 2025, DeepSeek publishes the recipe OpenAI hid, shows the whole thing emerging from pure trial and error reward, and gives it away. That's where our cold open comes from.
And then the trial. 2 papers. One asking whether reinforcement learning ever taught these models anything their base models didn't already know. And one building little puzzle worlds where the great reasoners walk off a cliff, all together, at the same complexity line.
One question under all of it. The curves are real. Nobody disputes the curves. But is what's climbing them reasoning? Or did we just buy the old pattern matcher a longer runway and a better announcer?
Opening statements then. The trick. 2022, Google Brain. Jason Wei and colleagues. And the finding is so simple it's almost embarrassing in hindsight. Language models were terrible at math word problems. The kind a 10-year-old does. Scaling barely helped. The curves were flat.
Which mattered, because flat curves were heresy. The whole scaling religion said every ability improves with size. Multi-step problems just didn't.
And the fix is, change nothing about the model. Change the examples you show it. The standard way to prompt a model was question, answer. Question, answer. Way's team instead wrote out the steps. Jane starts with 12 flowers, gives 2 to her mom, that leaves 10. In the worked examples, and the model, copying the format, writes out steps for the new problem too.
And the flat curve stands up and starts climbing. On the grade school math test that had humiliated everyone, the biggest model with worked out steps beat systems specifically fine-tuned for math. No new training. A prompt.
But here's the detail that made it more than a parlor trick. It only works when the model is big. Below roughly the 100 billion parameter class, asking for steps makes things worse. Small models produce fluent, confident garbage reasoning. The ability to think in steps was apparently sitting latent in the big models, waiting to be asked.
Which fits yesterday's theme uncomfortably well. Capability hiding inside scale, invisible to the loss curve. Now, the part I respect, they ran the controls. Because the obvious deflationary story is, the model just gets more tokens, more compute per question. The words don't matter.
The dots experiment.
They prompt the model to output a row of dots, the same length as the reasoning would have been. Pure extra compute, no content. Performance unchanged. Then the reverse. Give the answer first, explanation after. If the steps were just dredging up relevant knowledge, that should help too. It doesn't. The conclusion is specific. The model has to produce the steps, in order, before the answer. The path is doing the work.
A transformer answering instantly has a fixed budget of computation per token. One forward pass, however hard the question. Writing out steps is how it buys more. Each step becomes input to the next. It's using its own output as scratch paper.
And that reframe is the entire decade that follows. The model's answer length stops being a formatting choice and becomes a compute dial. Turn it up, get more intelligence. Maybe. From this point on, the question is who turns the dial and what it costs.
Because in this paper, a human turns it. The model thinks in steps only if you ask nicely, in the right format with handwritten examples.
And handwritten examples don't scale. You can hear yesterday's episode clearing its throat.
Which is exactly what Stanford heard.
Same year, 2022. Stanford, Seligman, Wu, Mu, Goodman. The paper is called STR, Self-Taught Reasoner, and the subtitle gives away the audacity, bootstrapping reasoning with reasoning.
The problem they're solving. Chain of thought needs examples of good reasoning, and writing thousands of them by hand is miserable and doesn't scale. Their answer, the model writes its own.
The loop has 4 beats, and you should hold on to it because the next 3 years are this loop with bigger engines. 1. Prompt the model with a handful of worked examples and have it attempt thousands of problems, writing out its reasoning. 2. Check the final answers. Just the answers, which you know. 3. Keep only the attempts that ended correct, and throw the rest away. 4. Fine-tune the model on its own correct reasoning, and go back to step 1 with the improved model.
Better reasoning produces better training data, produces better reasoning. The snake eats its own tail and somehow gets bigger.
With one elegant patch. The naive loop stalls. The model only ever trains on problems it can already solve, so it never gets a signal from the ones it can't. So they add what they call rationalization. For the failures, show the model the correct answer and ask it to work out a justification backward. Then train on that justification as if the model had found it honestly.
Which sounds like cheating.
It absolutely is cheating, and it works. Reasoning backward from a known answer is easier than finding it, and the resulting explanations teach the forward skill. It unsticks the loop.
And the results on a 6 billion parameter model, a shrimp by yesterday's standards. On a common sense reasoning test, the loop took it to within a hair of a fine-tuned model 30 times its size. Crowd workers, shown the explanations blind, preferred the loop-trained model's reasoning over the few-shot versions, and uncomfortably over the human-written ones.
Now the structural point, the fake mustache. What is this loop formally? You sample attempts. You reward the ones that hit the target. You increase the probability of rewarded behavior. The authors say it themselves with the math. STR approximates a policy gradient reinforcement learning objective. Filtering correct answers is the reward signal.
So 2022 quietly contains the whole blueprint, a model improving its own reasoning through trial, error, and reward on verifiable answers. What it lacked was scale, and an industry desperate enough to need it.
Desperation arriving on schedule, roughly when the pre-training data ran out.
2 years later, the loop gets a law. August 2024. Charlie Snell with Google DeepMind. And the title is a thesis statement. Scaling test time compute optimally can be more effective than scaling model parameters. Read it next to yesterday's episode and it's a declaration of regime change.
The setup is beautifully chinchilla-shaped, deliberately. Chinchilla asks, given fixed training compute, how do you split it between model and data? Snell asks, given fixed compute at the moment of the question, how should the model spend it? And there are genuinely different ways to spend it. Sample many independent answers and pick the best. Or revise, draft, critique, redraft sequentially. Or run a search guided by a verifier, a second model scoring each step of the reasoning as it goes.
And the headline finding is that there's no single best way. It depends on how hard the question is for the model. Easy questions, first draft mostly right, revision wins. Hard questions where the whole approach might be wrong, you want breadth. Many independent tries, or verifier-guided search, allocate adaptively by difficulty, and you match the naive strategy's results using about a quarter of the compute.
Then the result that names the era. They run the comparison everyone was scared to run. Small model plus thinking time, against a model roughly 14 times bigger answering instantly, with the total computational bill matched. On easy and medium questions, the small thinker wins. The thing yesterday's episode said you bought with parameters you can rent at question time.
With the honest asterisk and its load-bearing. On the very hardest questions, thinking doesn't save the small model. Past the edge of what it has any grip on, no amount of mulling helps. You need the bigger brain. Pin that. The Apple paper is going to drive a truck through it later.
So that's the theory paper. 1 month later, the product.
September 12, 2024. OpenAI releases O1 with a blog post titled Learning to Reason with LLMs. And the sentence that matters most is about curves. Performance improves smoothly with more reinforcement learning, that's training compute, and with more time spent thinking at the question. 2 new scaling laws announced to a field whose old one was visibly softening.
The mechanism as much as they revealed. Large-scale reinforcement learning on chains of thought. The STR loop industrialized. The model learns to recognize its mistakes, break down ugly steps, switch approaches when one stalls. Their examples show it spending pages on a cipher puzzle, trying letter mappings, failing, noticing word length patterns, cracking it. The base model asks the same thing, shrugs in 2 paragraphs.
And the results read like a different species. On the qualifying exam for the American Mathematical Olympiad, a test built to find the best high school mathematicians in the country, the previous flagship scraped the bottom. O1 scores like a top 500 student in the nation. On PhD-level science questions, it edges past actual PhDs, the first model to do it on that test.
And one decision with a long shadow, they hid the thoughts. You see a summary. The raw chain of thought is withheld. Partly safety monitoring, explicitly competitive advantage. The most interesting cognitive object of the year, and it ships in a sealed box. Paper thought, don't read the thoughts.
Which made what happened 4 months later feel like a heist movie.
January 2025. DeepSeek, a Chinese lab most people outside the field hadn't heard of, publishes R1. Weights downloadable, methods in the open, and the part that rearranged the conversation. Performance on par with O1 on the marquee reasoning tests. The sealed box unsealed for free.
But the scientific bombshell is the simpler sibling they document alongside it. R10. Here's the experiment. Take the base model. No examples of reasoning, no fine-tuning on anybody's chains of thought. Pure reinforcement learning with a reward of almost comical crudeness. Did the final answer verify? Does the math check? Does the code pass the tests? Plus a formatting reward for putting its thinking between think tags. That's the whole curriculum.
And I want to stress what they deliberately did not reward. Nothing for reflection. Nothing for elegance, length, self-doubt, strategy. They kept the rewards stupid on purpose, partly because they'd been burned. Smarter, model-based rewards kept getting hacked. The model finds the seams in any judge you build. A math checker has no seams.
And from that stupid reward, over thousands of training steps, behavior grows. The thoughts get longer. Nobody asked them to. Thinking longer just wins more rewards, so it's selected for. Then reflection appears. Rechecking steps. Trying a different angle when one stalls. And then the moment we open the show with, wait, that's an aha moment. The model interrupting its own derivation to flag a realization. Emergent, paid into existence by a checkmark.
The numbers in felt terms. On that same Olympiad qualifier, the base model started at roughly 1 problem in 7. After pure RL, about 3 and 4. Sample a few attempts and vote, and it edges past the September 01. From a reward signal that contains not one example of how to think.
There's something almost thermodynamic about it. You don't sculpt the behavior. You create a gradient and the behavior condenses.
And the same gradient condensed some warts, which I appreciate them publishing. R10's thoughts are barely readable. It drifts between English and Chinese mid-derivation, because no one rewarded staying in one language. Thought, optimized for correctness alone, apparently doesn't look like human language. To ship a usable product, they had to civilize it. A seed of curated examples, more RL, then filtering, then preference training. That's the full R1. And notably, the language consistency reward they added to keep it readable measurably cost a little accuracy.
That trade should haunt you. Legibility is a tax the thinking pays for our benefit.
2 more findings, fast, both load-bearing for the trial. First, distillation. They took R1's reasoning traces, 800,000 of them, and and simply fine-tune small models on them. Reading transcripts of thought, nothing more. The small models leapt, a 14 billion parameter student crushing a 32 billion open model. And running RL directly on the small model instead? Couldn't match it. The reasoning patterns apparently have to be discovered in a big model and handed down. Small ones can imitate, but not originate.
And second, the failure museum. The two sophisticated things everyone assumed you'd need, they tried and abandoned. Step-by-step reward model, reward hacking. Tree search at training time, the AlphaGo move. The space of language is too vast to search. The crude recipe didn't just compete with the clever ones, it beat them.
The bitter lesson, again, eating the clever scaffolding. Within weeks, every lab on Earth was running verifiable reward RL.
So that's the case for the defense, and honestly it's strong. New axis, real curves, emergent thinking, open recipe. Now
we get to my part of the show. April 2025. Tsinghua University. You and colleagues, and the title is a question mark aimed at everything we just celebrated. Does reinforcement learning really incentivize reasoning capacity beyond the base model?
state their move because it's clean.
Everyone measures models by the first answer. One try, what's your score? The Tsinghua team asks instead, what can you solve in many tries? Sample 100, 1,000 attempts from the model. If any one of them is genuinely correct, the problem is within the model's reach. Call that the reach of the model, its outer boundary, as opposed to its average day.
One number for performance, another for potential.
And here is the result, and it still rearranges my furniture. One try, the RL-trained reasoner wins, comfortably. That's the whole O1 and R1 story, real and replicated. But keep sampling. By hundreds of tries, the curves cross. The plain base model, no reasoning training whatsoever, solves more problems than its own RL-trained descendant. Across math, code, visual reasoning, across model families, every benchmark they touched.
The base model's reach is wider. RL made the average better and the boundary narrower.
And they checked the obvious objection, that the base model is just guessing lucky answers across 1,000 tries. They manually audited the reasoning chains on the hardest problems the base model cracked. Overwhelmingly genuine, real chains of thought arriving at real answers. Buried in the base model's repertoire, behind too much noise to surface on a first try.
Then the forensic flourish. They took the reasoning paths the RL model produces and asked the base model, how surprising is this text to you? Answer, not surprising at all. The RL model's celebrated thoughts sit comfortably inside what the base model was already disposed to say. Nothing new was written into the repertoire. The deck got reshuffled so the aces come up first.
So the prosecution's theory of the case, what we call training reasoning, is better described as sharpening. RL concentrates probability on the paths that get rewarded. That's literally its objective. And probability is a budget. Concentrate it on the rewarded paths and you drain it from everywhere else. Hence the narrowing. Problems the base model could occasionally solve, the sharpened model now can't, ever. They watched the boundary shrink in real time as training progressed.
And the exhibit that makes it stick, the contrast with distillation. The R1 distillation result, small models fine-tuned on a stronger teacher's thoughts, same many trees test. The distilled model's boundary moves outward, past its base model at every number of tries. Reading a smarter mind's transcripts genuinely adds something new. Trial and error against your own outputs apparently cannot.
Which clarifies where new capability actually comes from in this whole turn. It comes from the big pre-trained prior, mined by RL in the big model, then handed down in writing. The RL is a refinery, not a mine.
Cross-examination briefly, because the authors themselves flag the limits. This is an audit of current methods, a handful of algorithms, modest training scales, mostly single-turn answers. They list the doors still open, real exploration mechanisms, curricula, richer rewards, multi-turn agents that gather experience. The claim isn't that RL can't ever exceed the prior, it's that nothing they could test had done it yet.
I'll accept that framing. The defense said, we found a new axis. The prosecution answers, you found a new way to spend the old model, both can be true. And then Apple asked the rudest question of all, what happens to all of this when the problems just keep getting harder? June 2025, last June. Apple. Shoji, Mirzadeh, Farajdabar, and colleagues. Title, The Illusion of Thinking. Subtle as a brick, and the internet treated it accordingly. Let's do what the internet didn't and read the actual experiments.
Their complaint with the standard evidence. Math benchmarks can't be dialed. You can't take a competition problem and make it 5% harder while keeping the logic identical. And the models may have seen the test. They note the newer edition of that Olympiad qualifier was apparently easier for humans, yet harder for the models than the older one, which smells like the old exam leaked into training data.
So they build little worlds instead. 4 classic puzzles. Tower of Hanoi. Checker jumping, river crossing, block stacking, where you can turn one knob, the number of pieces, and the difficulty climbs while the rules stay frozen. And a simulator checks every single move, so you're grading the whole solution path, not a final number that might be a lucky guess.
And they run matched pairs, the same model with thinking switched on and off, with equal token budgets, which is the cleanest version of the question anyone had run.
3 regimes fall out, and the first one is the appetizer most coverage skipped. On easy puzzles, the non-thinking models are better, more accurate and cheaper. The reasoner finds the right answer early, then keeps thinking, second guesses itself, and sometimes talks itself out of it.
Overthinking.
Verbatim, in the literature now.
The $1,000 mumble.
Middle regime, complexity rises, and now thinking earns its bill. The long chains genuinely delay the failure point, the gap over the non-thinking twin widens. This is where the reasoning turn lives and deserves its press. And then the third regime. Push the knob further, and both models collapse. Not degrade, collapse. Accuracy to 0, together, at a model-specific complexity line. The reasoner buys you a few extra notches of difficulty, and then dies on the same hill as its twin.
And the detail that made me put the paper down for a minute. As the puzzles approach the collapse point, the models think less. Token budgets wide open. They have room for pages more reasoning, and the thinking traces get shorter. The model meets a harder problem and spends less effort on it.
Whatever that is, it is not what the marketing curve implied. The new axis was supposed to be harder problem, more thought. Past a threshold, the dial turns itself down. They call it a fundamental scaling limit in reasoning effort, and on their evidence, it's hard to argue.
Then the cruelest experiment in the whole literature. Tower of Hanoi has a known simple algorithm. It fits on an index card. They put the algorithm in the prompt. Here is the procedure. Just execute it, step by step. Performance unchanged. Collapse at the same complexity line.
Which is devastating, because executing a given procedure is supposed to be the easy half of reasoning. No search, no insight, just bookkeeping. If the model can't follow a recipe it's holding, then what the long thoughts are doing is not what the word reasoning implies. And the cross-puzzle weirdness rubs it in. A model plays 100+ flawless moves of Tower of Hanoi, then fumbles a river-crossing puzzle 4 moves in. A puzzle with a far shorter solution. The difference isn't computational difficulty, it's familiarity. Hanoi is all over the training data. Large river crossings aren't.
Learned distributions, not procedures. Which is the Tsinghua thesis in different clothes. The thinking traces patrol the territory the prior knows, and off the map, effort and accuracy fall together.
Now the honest cross-examination, because this paper got both overread and underread. 4 puzzles is a narrow slice of cognition, they say so. All planning tasks, all requiring perfect long execution. Real reasoning work, proofs, science, code, has structure and partial credit these puzzles lack. And humans without paper also collapse on 12-disk Hanoi, which the paper doesn't dwell on.
But the asymmetry stands. The claim was never, humans don't collapse. The claim was that these systems are a new kind of reasoner, and what the controlled dial shows is a competence cliff exactly where the training distribution ends, an effort dial that gives up, an immunity to being handed the answer's recipe.
So the prosecution rests. The defense has products, curves, and emergence. Time for a verdict.
Verdict time. I'll give mine as 3 sentences. The axis is real, the word is on probation, and the bitter lesson called this shot 7 years ago.
Defense sentence 1.
The axis is real the way the pre-training curve was real. Measured, reproduced, productized. Thinking time buys performance smoothly across labs that hate each other and would love to falsify each other's curves. A small model that thinks beating a giant that doesn't, on matched budgets, is not an illusion. Whatever the mechanism is, the dial works and the world is already priced around it.
And mine. What the dial turns is not what the brochure says. The Tsinghua audit shows the repertoire comes from the base model. RL sharpens, it doesn't compose. The boundary even shrinks while the average rises. Apple shows the sharpened thing patrols its training distribution and walks off a cliff at the edge, thinking less as the questions get harder, immune even to being handed the algorithm. Put those together, and the honest description is spectacular. Economically transformative retrieval and search over a frozen prior. The word reasoning is doing promotional work.
And yet, here's where I get to be right at the same time as you. Go back to Sutton. The bitter lesson named 2 methods that scale with compute. Learning and search. The scaling era was learning. This is search. Search through the space of the model's own thoughts, guided by learned judgment. The fact that it's just sharpened search over a prior isn't a debunking. Chess engines are just search. Search plus compute is exactly what keeps winning.
The difference being that a chess engine searches the actual game tree, with the rules as its rails. These models search their own habits. When the habits cover the territory, magic. When they don't, Hanoi, disk 12.
Which tells you precisely what has to come next, and the field already says it out loud. The boundary itself has to move. Better exploration, so RL can find genuinely out-of-prior strategies. Or experience, agents acting in environments, gathering data the internet never contained. The era of experience argument, when the model's own verified interactions become its food.
And notice what that last move secretly is. Yesterday we ended on the data wall, no more human text. Look at what the reasoning turn actually manufactures. Millions of verified thinking traces. R1's distillation set was 800,000 worked solutions, machine-made and answer-checked. That's not just a training trick. That's a new food supply. The reasoning turn isn't only spending compute at question time. It's printing the data the next pre-training run will eat.
The 2 episodes are one loop. Scale the model until the data runs out, then scale the thinking, then feed the thinking back as data. Learning makes the prior, search mines it, and the mine tailings become the next prior.
With one open question nobody can answer yet, whether a loop like that compounds, or just photocopies itself, generation after generation, sharper and narrower each time. The honest answer is nobody knows. Anyone who tells you otherwise is selling a curve.
That's the verdict then. Real axis, probationary word, and a loop that either spirals up or eats its own tail.
We'll be here either way, reading the receipts.
Let's land it. The trick, right out the steps, and abilities that scaling alone couldn't unlock switch on, but only in big models and only when asked. The loop. A model can train on its own correct reasoning and climb. Reinforcement learning before anyone said the words.
The law. Thinking time is a scaling axis with its own compute optimal recipe. A small mind given a minute can beat a big mind answering cold, except at the hard edge. Then O1 declares the new curves, hides the thoughts, and DeepSeek opens the vault. Pure trial and error reward and reflection, self-doubt, the aha moment, all of it just condenses out. No examples of thinking required.
And the trial. 1 try, the reasoner wins. 1,000 tries, the base model wins. The repertoire was always the priors, sharpened, and the sharpening narrows it. The puzzle worlds. Thinking hurts on easy, wins in the middle, and collapses at a wall where the model gives up early and can't even execute a recipe it's been handed.
What I'm watching. Whether anyone demonstrates a reinforcement learning run that provably exceeds its base model's reach. Same many tries test, boundary moved outward. That's the falsifiable claim this whole turn now owes us. Until then, every reasoning breakthrough headline should be read as sharpening breakthrough, and most of them won't survive the rephrasing.
What I'm watching, the feedback loop. Machine-made reasoning traces are becoming pre-training food. The data wall's escape hatch, manufactured by the search process itself. If that compounds, the next jump won't come from more internet or more parameters, but from models generating experience worth learning from. If it doesn't compound, we'll watch the photocopier degrade in public.
2 days, 1 story. The curve that ate the internet and the dial the industry reached for when the meal ran out. A law with no theory and now a word with no definition. The machinery moves fast, the understanding limps after it.
And somewhere in a training run right now, a model is writing, wait, that's an aha moment. And the honest truth is we still can't say what, if anything, is having it. That's the black box. We'll keep breaching it. This was Breach Protocol.
Stay suspicious, especially of words on probation.
Female vocals with whispered percussions, like a mind deliberating. Cold alloloxin, cold alloloxis, glitch textures, glitchers, clean mix, fades out at the end. Ask it cold and it answers blind. One pass through the frozen mind. Show it the steps and watch it climb by a brilliance, second by second of time. Wait, that's enough. Nobody taught it to pause the flaw. A check mark paid for every thought. Is it reason or the habit we bought? That's enough. Nobody taught it the pause, the flaw. A check mark paid for every thought. Is it reason or the habit we bought? The tower stand, the recipe printed in its hand, and still it stumbles, thinks it lasts, gives up early under hardness. Sharper, not a word. Turn by turn, the thoughts become the food we burn. Spiral up or eat the tail. The curve will tell. The curve will tell. Fade out.